Let's look at questions 8 and 9. So which of these samples of gas contains the largest number of molecules? Well, first of all, another way of looking at that is you get the number of moles and then you multiply by Avogadro's number to get the number of molecules. So another way of saying this is which of these has got the largest number of moles, because you're going to multiply each of them by the same number, Avogadro's number, to get the number of molecules. So you can miss out that step and just reinterpret this question as saying which of these has got the largest number of moles. So how are we going to do that? Well, PV equals nRT. You've got to use PV equals nRT. I would think that's fairly obvious because you've got R, the gas constant, in there, and PV equals nRT is the only equation you know with the gas constant in there. N is the number of moles, so you've got to rearrange it. Let's have a look at spoilers. So PV equals nRT, divide both sides by R and divide both sides by T to cancel the R and the T on that side. So N equals PV divided by RT. So I've got to work out PV and divide by R and T. Well, let's have a look at these. Pressure is in pascals, so sometimes it's in kilopascals and you need to multiply by 1000 to turn into pascals, but none of these are in kilopascals, so that's fine. So pascals, the pressure here is fine. Temperature in Kelvin, so sometimes you've got to convert degrees Celsius into Kelvin by adding on 273. So 273 add degrees C turns it into Kelvin, but they're all in Kelvin. So our pressures and our temperatures are all fine in the same units. However, look at some of these. A and B, the volume is in meter cubed, and that's correct. Whereas these ones, C and D, it's in decimeter cubed. So I need to get everything into meter cubed. So the volume has got to be in meter cubed. So how do I turn decimeter cubed into meter cubed? Well, the answer is that I've got to divide by 1000. So to turn decimeter cubed into meter cubed, you divide by 1000. If you want to know how that works, well, think about what a meter cubed is. A cube has got a length, a height, and a depth to it, a width. So you multiply those three values together to get the volume of a cube. So length, height, and depth or width. And a meter is 100 centimeters. So 100 multiplied by 100 multiplied by 100 is 1 times 10 to the power of 6. 1 with 6 zeros after it. A decimeter cubed is 1000 centimeter cubed. So a meter cubed is 1 times 10 to the power of 6. A decimeter cubed is 1 times 10 to the power of 3. Or in other words, you could say a meter cubed is 1,000,000, 1 with 6 zeros, centimeter cubed, and a decimeter cubed is 1000 centimeter cubed. So a decimeter cubed is 1000 times smaller than a meter cubed. So you've got to take this value and divide by 1000 to turn decimeter cubed into meters cubed. And then if you put the numbers in, N is this value, so N is P times V, so 5 times 10 to the power of minus 4, 5 times 10 to the minus 4 is your volume multiplied by your pressure, which is 1 times 10 to the power of 6 there. So 1 times 10 to the power of 6 is your pressure. This is your volume, 0.0005, 5 times 10 to the minus 4, divide by R, divide by T, and it comes out as 0.2. You do the same for all of them. Remember, you've got to take this 3 times 10 to the power of 1 and divide by 1000. So 3 times 10 to the power of 1 is 30 divided by 1000. So you've got to divide these two by 1000 here. That's why those two have got divided by 1000 to turn decimeter cubed into meter cubed, and therefore you come up with the answers, and 0.24 is your highest number of moles. You could multiply each of these by Avogadro's number, but you'd still find that B is the highest value. Which of these substances, question 9, which of these substances has permanent dipole-dipole attractions between the molecules? CCl4, C2F4, CH3 twice CO, so that's propanone and carbon dioxide. Well, let's have a look at the molecules first of all. So CCl4 is carbon surrounded by 4 Cls. C2F4 is double bonded carbons surrounded by 4 Fs. Propanone is CH3 with a C double bond O in the middle. It's a ketone, propanone, and carbon dioxide is CO2. If you've got permanent dipole-dipole attractions, it means that any polar bonds, that is, any bonds with delta plus and delta minuses, will not cancel each other out. So say for example CCl4, there's a polar bond there between the C and the Cl. Cl is electronegative, can have a small minus charge, the C will have a slight plus charge, but because it's completely symmetrical in both the y and the x-axis, all of the polar bonds, the delta plus and delta minuses, cancel each other out, and therefore you don't get permanent dipole-dipole attractions between the molecules, because the overall charge here in all directions cancels each other out. So another way of looking at this is, which of these has permanent dipole-dipole attractions between molecules? In other words, is not completely symmetrical. If it's completely symmetrical, you won't get permanent dipole-dipole attractions between molecules. So CCl4 is permanent, has no permanent dipole-dipole attractions because it's completely symmetrical in both the y-axis and the x-axis. If we look at C2F4, that is, then it's symmetrical about the y-axis and it's symmetrical about the x-axis. Propanone, C, I think is your answer here, because if you look at it, it's got symmetry, it's symmetrical about the y-axis, but it's not symmetrical about the x-axis. If you look on the x-axis here, you've got a C double bond O coming up, but you've not got a C double bond O going down. So that's going to have permanent dipole-dipole attractions because that molecule is not perfectly symmetrical in both directions. Carbon dioxide, let's just check this out. It has a line of symmetry, is symmetrical about the y-axis and the x-axis, so that won't have permanent dipole-dipole attractions between molecules. Your answer is C.